had found the geometry of perfect equilibrium from the polarity of the two isotropic vector metrics coming together. Why is this geometry, for instance, the only geometry that's in perfect equilibrium? Well, I studied a little bit and I realized that actually, if you have vectors of forces and you want to create equilibrium, then you would have, obviously, now, this vector that just popped out could express a force. And we'd say that that force has this specific unit which relates to the length of the vector. So bigger the vector, stronger the force, smaller the vector, smaller the force. If you wanted equilibrium, you'd send another vector in the exact opposite direction at the exact same length, and you'd get equilibrium. However, this would be a very precarious equilibrium. Nature could not use that equilibrium because any distortion would make the vector collapse. Any forces in any other direction would break the equilibrium. So it was very unlikely that the universe used that type of equilibrium. Well, what would it do? Because this is unstable. What would it do? Well, if you were trying to get an equilibrium yourself, you would probably say, well, I'll just keep adding vectors. Well, if you add vectors at 90-degree angle from the initial vectors, you're still not going to get equilibrium because now what's going on is that the edge vectors are longer than the vectors to the center, so they're stronger, it implodes, it doesn't work. No equilibrium. So what would you do? You probably continue to add vectors, and you would probably put them at 45 degrees from the initial one. And now you have another problem. That is, the edge vectors are shorter than the vectors to the center. Now the geometry explodes, is still no equilibrium. So what would happen is that you would have to make sure that the geometry's edge vector and vectors to the center are the same length. And the only geometry in this happens to be like the snow crystals, the hexagon, where the edge vectors are the exact same length as the vectors to the center. And if we made a 3D hexagon together, we would get a vector equilibrium, which is made out of 12 vectors radiating from the center and 12 edge-bounded vectors that maintains the structure in